Okay, if you hear noises in the background, it's my 3D printer going, so don't worry about that. And the dog may bark if he gets distracted. But anyway, talking about Simulation Express here, and those are the two, well, the single icon up there, as you can see, it says Simulation Express Analysis Wizard, and also we do have a Flow Express Analysis Wizard. And we're going to start with the wizard, and then we can progress on to greater things in weeks to come. So from Moodle, you'd have got the drawing for the dog bone, and it's only a couple of mil thick, but we need to apply some stresses and strains onto it. So because I've already just pressed the Simulation Express, I get the menu appear on the right hand side. If I just close this down, I'll just do that once again. Okay, do you want to save? No, I don't. Okay, that disappears. So at the top, and again, if you don't have this bar at the top, you just right hand click here, go to toolbars, go down to tools, that switches it off. Do the same again, toolbars and tools. Okay, there's a lot of useful little bits of gadgets there. And I would have shown you when we do this how to actually apply materials. You can see in here we've got a polypropylene copolymer, and the data we can look at, we'll look at in lesson. So to actually start Simulation Express, you just have to go to the icon, click it on, and this appears. So I can go to options. Just if I go to options for a second, systems of units, we've got the SI units. We don't want to do the English IPS, just SI for now. And results location, it's going into a temporary file. You can stipulate which way or where you want it to go. So let's go to next. Right, you'll see on the right hand side you get a whole list of fixtures, a whole list of 6 options to look at here. And so I'm going to do this very simply. So I need to add a fixture, and this is how the actual product is anchored for the test. You can see from the little icon on the left, the motion icon, that it's really asking us to actually choose a face. And also here you can actually choose points, and if I just hover over, if I just turn it around, you can see what it's wanting to do. And if I do to an end face, side face, if I do to an end, so I can hold it in different positions just to get the data. So for now, because it's a tensile test bar, I'm going to anchor it on that end there, so that's face 1 on there. So I'm happy with that. So I can don't need to add fixture at all, so just go to the green tick either there or up at the corner here, and that's that there, and they stay. So that's permanently fixed. You can go back and edit them, but on that one, and I still get the choice to add more fixtures. So if there's more points of contact, I can add those in. I want to go to next. So if I go to next, and I want to add a force or a pressure, I actually want to add a force. Now this is a tensile test, so it's going to be pulled. So this is one end. So I'm going to go to add force, and again I should have another window up, and it's asking me for a face. Now it's a force or pressure, very similar things to look at, but you can see again if I hover over, it's there, but I want it the opposite end to the way it's been held. So I'm just going to click on there, and I'm actually going to reverse the direction of that. You'll also notice it actually default set is at 1 Newton. Okay, now since gravity is 9.8, which is the equivalent of probably around about 1 kilogram, I'm going to set that to 10 newtons. You know, a bag of sugar, if you're trying to pull 1 kilo, if you're in the gym, you know how much weight you're doing, you can then transverse that to newtons. So I'm going to leave that there, and I'm going to agree to that, give it a green tick, okay, and go to next. Now it's asking me again about the material. So yes, it's a polypropylene copolymer. It tells me what the Young's modulus, that's already been calculated from tables. Its yield strength. I could change the material, or I just go to next. That's just a double check. That's exactly what I want to have. Go to next. Okay, I could go change settings here, or I could run simulation. I want to run the simulation. Okay, and it's running it for now, and nothing is actually happening. Yes, it is. Okay, so you can see there, okay, if I look at that, it's actually pulling in the direction, and you can see, if I just press the space bar again, it comes in. You can see the sort of deformation that it's doing, and it's going to ask me, is this what we expect? Now, having done these tests, yes, it is what we expect, but we can now add in some more interesting data. So it says, does the part deform as you expected? Yes, it does. So I just click on yes, and then it asks me, does it want me to show von Mrs. stress? Yes, I think we do. Okay, so there we go. And obviously where the red parts are is where the most stress is, and where the blue parts are where the least stress is. And then you've got sort of intermediate on the green. Do I want to see displacement? Yes, I do. On that, I did click that. Yes, I did. We can see that, and show where factors of safety is below 1. Now we can talk about factor of safety. Hopefully you've done this, but generally 1 is as is. If I design stuff, I always look at a safety factor minimum of 2, so we know it will do stuff. Some projects I've worked on, you can go up to factors of 5 on there. So this time I'm going to go again, play animation, and you can see it actually does it in color in that way. So that really is the basics of it, and we can actually do a report. So when you've done that, see if that changes on there. I can either stop the animation, and again you can see the area. Normally that is the point of failure, but actually on this it would be actually where the yellow. So if we look at the sort of 1 kilo mark, this actually is quite good. If I go back, let's see if we can go back and do it. Let's go back and change that, and see actually what happens. Let's go back again and back again. I don't want to change material, I just want to change the actual weight. So edit existing force pressure, and it should come up there. I can double click on there and it should come up. There we go. Let's put that at 100 just to be awkward. That's 100 newtons. Let's see what happens now. Okay, let's go carry on. So we've done that. Let's go to run. Let's run simulation. I'm thinking about it. It may take a little bit longer because there's a lot more to compute. Okay, the deformation looks about the same. Let's just continue, and let's have a look at the von stresses. Very similar again, and let's play animation. That does it. Yeah, I would have to do a comparison between the two in terms of separate reports, but we can go do that. So it says here, generate report, generate e-drawings file. I want to generate report, but make sure you've got Word open on the desk. If you don't, it won't find it. So just click on generate report. Okay, and it's asking me, you can put your information in here to do it. So designer, if I just put in me. But again, this is very simplistic. You can put other aspects to it here as well. Go to generate. Okay, I've already got one open. Let me just go and close this one. File close. Okay, we've done that one. Let's just see. Generate. Let's try again. Let's replace it. Yep. And go make a cup of tea while we're waiting. There we go. It's starting to generate the report. I don't know why this does this to 3/4, because it would be better in a well, it'd be easy if you could choose to actually do that. It's just going through the motions. Nearly there. Not long to go. Oh, still 64%. There we go. It jumps up. Now, it's not telling you. This is for you to interpret and to actually write notes on. And hopefully you've done some of this already in the last 2 years. So here comes the report. So simulation of dog bone, it depends on what file format. You add a description of what you're trying to do. Your assumptions, so that's where your points are. Gives you aspects here, gives you the mass, your volume, your density, weight. These can be changed. The type of material, where it's fixed, where the force is applied, and it gives you your mesh information here in detail. If you zoomed in on that, you'd actually see the mesh makeup. And also in terms, then you've got the studies. So if on misses stress, and obviously it will go in the middle. It'd be nice. You may have done this already in the years, and you'll see where it goes. And again, if you look at the displacement side of stuff, where the failures are likely to be, and then you can write your conclusion. So it kind of does it for you in that way, and I think it'd be quite practical for you to have a go at doing bits and pieces. With the version of SolidWorks you've got the full gamut. I have only got the Express here at home, so that's why I wanted to set you up on this and in lesson, and once I get a laptop back we can maybe go in a little bit more detail. And again, that was with 100 newtons for that, which is not a lot of difference between the two. So hopefully that will get you started on using the SolidWorks simulation package. Excellent.